Hello friends, this is Arpan Gupta, and in this video I am going to explain you about an algorithm, machine learning algorithm, which is support vector machines. So we will understand with an example. So let's take an example of a giraffe and a camel in a forest, and you want to identify them using a computer. So how you would do that? So in order to teach computer on how to distinguish between them, we need to create some features of these animals so that the computer can understand. And how do we do that? We make those features. So these features can be length of the animal. It could be whether the horn or hump is present. It could be a binary feature. Take hump and horn as two binary features. If hump is equal to 0, that means hump is not present, which isn't the case of giraffe. If hump is equal to 1, that is a camel. So these are two binary features. One is horn and the other is hump. Now if you plot these animals data points in two-dimensional space, we can see that a line can separate these two classes or these two animals in two-dimensional space. This is called a linear support vector machines. The blue dot over the blue dotted line is called a support vector. Similarly, the two red points on the red dotted line is also called a support vector. The distance between the red and blue dotted line is called the margin. And the support vector machine algorithm aims to maximize it. The black middle line is called the hyperplane. The support vectors are named as support vectors because the hyperplane is decided on the basis of these support vectors. Or in other words, the hyperplane is supported by these data points which are called support vectors. Or in other words, we can say if one of the support vector data point is removed from the data, then the hyperplane will change. But let's say we have data points in the space which are not linearly separable, then we need to use some kind of trick which is called kernel trick, which actually transforms the features into higher dimensional space, which basically applies a function to the input variables. It can square, it can cube, or it can apply some logarithmic function or exponential function. So different kind of functions you can apply to the input variables. So these are kernel tricks. It basically transforms the lower dimensional space into the higher dimensional space in such a space where the data points are linearly separable. In this figure, we can see that the left data points are transformed into higher dimensions on right, and then we can see that it can be separated by the straight plane. Some common kernels which can be used are polynomial, Gaussian, hyperbolic, sigmoid. These are kernels which depends on the data we have, and so that the data points which are not separable in the current space can be transformed into other higher dimensional space by using one of these kernels, so that we can separate these data points into categories by using some classifier. Support vector machines. Now the important advantages of support vector machines are it avoids overfitting and uses kernel trick. Disadvantages is time complexity, which is high in this case. It takes a lot of time to train an algorithm. Now the important applications of support vector machines are face detection and the classification of images. There are many more applications. So this is all about in a very basic of support vector machines. Please do like and subscribe this channel so that you can get more notifications on the future videos.